On your handout you have this diagram, and there's just a couple of bits for you to do on it. And you have a voltmeter tucked away somewhere, and the idea is that the ends of this wire, this conductor, are connected to the voltmeter. And hopefully the idea is that if we could keep the voltmeter connected, that as this conductor moves through the magnetic field, this would indicate the voltage which is induced into it. So let's have a look at the factors in play. The first one is within the magnetic field between the poles, the flux density. So how dense the field is, that's important. The next one is the length of the conductor in the magnetic field. So I'll stress again, if this is 10 meters long, but this is only 10 centimeters long, then the only length of the conductor is 10 centimeters. It doesn't matter how long the cable is, it's what is contained within the magnetic field. So that's the first two factors, flux density, the length. The third factor is the speed, the velocity. That's lowercase v. The faster we can move the conductor through the magnetic field, then the higher the induced EMF. So that gives us the formula E equals B L V, and that is in volts. So on your handout there is a box for that. Then there are a couple of examples to do. Let's have a look at those right now. Probably move on to another sheet in a second. So example 1. Look at the question, E equals B L V. Put the numbers in. And that comes to 3.75 volts. Okay, so that's nice and simple. That's the first example. If we do the second example, do it on the back of this to save a bit of paper. So the second example needs you to do a transposition. So our base formula, E equals B L V, we need to transpose that, and the velocity is what we're trying to find. So V equals E over BL. So in this case, leave V on the top line, and B and L have moved diagonally underneath E. So that's that. We'll talk about that again in a second. Put your numbers in, and the EMF was 25 volts, flux density 0.5 and 48. And if you put that into your calculator, I'm hoping you're gonna come up with 1.04 meters per second. So I did say I'd come back to this. If you don't like the transposition, then it will go into a triangle. Looks unusual. So here we want a velocity. Velocity gives us E on the top and B times L on the bottom. E on the top, B times L on the bottom. So I'm not happy about that. I'd rather you used your brains and did the transposition properly.